question 7. So for part A, sketch a speed time graph for the motion of the train between the two stations A and B. I've done that up here. All you actually needed to get full marks for this is the bit that I've done here in blue. The other bits that I've added are really to help support the arguments later on in the question. So you didn't have to do much. So it's obviously velocity and time, accelerating for a while, then constant velocity for a bit, and then decelerating. I think it makes sense though to make that steeper than that, because you were accelerating at a faster rate than you were decelerating. Right, part B. Find in terms of V the length of time in seconds for when the train is these three things. So when it's accelerating, so that's this part of the graph here. So what do we know while it's accelerating? Well, our initial speed u was 0. We know that the time taken I'm going to call t1, and we're told in the question that we're accelerating at 0.5 meters per second squared, so a is 0.5. So using v equals u plus at, as I said, u is 0, so our time, t1 I'm calling it, is therefore v over a. The acceleration is 0.5, so v divided by 0.5 is the same as v times 2. So for part 1 the answer is 2v seconds. Now for part T, in terms of v, the length of time, well, we're decelerating, so this period of time here, which I'm calling t2. So for this journey here, our initial speed, our u, is actually our v. Okay, it's our constant speed we were travelling at. So our initial speed u is v. Our final speed v is 0, because we come to rest at b, and we know we're decelerating at 0.25 meters per second. So our acceleration is minus 0.25. So u is v, v is 0, and a is minus 0.25. So substituting into v equals u plus at and rearranging, we get this period of time, which I'm calling t2, to be v divided by 0.25, in other words 4v seconds. Now for part 3, we're trying to work out the length of time when it's moving with constant speed. So this period of time here, which I'm calling t3. Now we're told that the total time for the journey from A to B is 5 minutes. So from A to B is 5 minutes. That's 300 seconds. So all of that is 300. We'd worked out t1 to be 2v, t2 to be 4v. So our t3 is going to be 300 minus 2v minus 4v. In other words, 300 minus 6v seconds. Now for part C, find the value of v. Now we know that the distance between the two train stations is 6.3 kilometers, which is 6,300 meters. Now the distance represents the area under a velocity time graph. So the area of this trapezium here is 6,300. So that's what I'm doing down here. How do you work out the area of a trapezium? Well, you average the two parallel sides. So the length of the base from A to B is 300. The length of this parallel side here is 300 minus 6v. And once you've averaged them, you add the two together and divide by 2. So that's what I'm doing here in the square brackets. And then you multiply that average length by the height of the trapezium, which is v. And as I said, this equals 6,300. So there we have an equation to solve, with v being the only unknown. So what have I done? I've multiplied through by 2, and then I've obviously simplified the numerator. The numerator is 600 minus 6v, and I've multiplied through by 2. Then multiply at the bracket, rearrange to and make equal to 0. I get this quadratic equation, divide through by 6 and solve the quadratic. I get v being either 30 or 70. Now we're told that v is less than 50, so our v must be 30. So v, the value v is 30. 30 meters per second really, but 30